Hello, all my JavaScript friends. This is TheVirtuoid, aka Mike Smith, and this is our snake game. This video, we're going to be taking a look at the pitch. What is the pitch? Well, this is the playground in which the snake slithers around, whether it's a 2D pitch, is what you're seeing here, or a 3D pitch, or a 4D pitch, or a pitch on HTML, a pitch on a terminal. It doesn't really matter, or a VR pitch. The snake needs to go on something. We need to have a fence around something. We also need a place where the prizes get dropped or the bombs get dropped, and that is the pitch. And basically the pitch is a very, very simple little object here that says, hey, what's the size of my pitch and what's the idea of my pitch, and has something collided with something within the pitch? And that's it. There's really not a lot to it. Let's take a look at the design itself. Again, very simple. The first one is going to be dimensions. Now, this is a vector. A lot of vectors I've talked about earlier has either been a position vector in which this position says, hey, at this particular, I'm going to use 2D for example here, this particular XY combination here is a particular point somewhere in space. I've also had direction vectors, which basically says, hey, the XY represents a direction that this particular object is supposed to move whenever it moves. This is a third part of a vector, and this basically means dimensions, and this represents the size of something. So, for example, let's say we had a 40 by 40 screen. Yeah, for instance, like this one right here. This one happens to be a 40 by 40 pitch. So when I declare my dimensions, I'm going to declare it as 40, 40 as the new vector. And what a dimension vector basically assumes is that the beginning vector is, or the beginning position is always 0, 0, and that the x, and I'm using 2D here, for example, the x represents the size of the number of columns, while the y represents the size of the number of rows. So, a 40 by 40 dimension would have the range would be 0 to 39 on the x-axis and 0 to 39 on the y-axis. So that's why we have this as a vector, and this is a dimension vector. It basically allows us to do sizes. And our real only method we have here is the collision method, because we need to be able to figure out if there's some sort of collision has occurred with from any position within this particular dimension. Now, what constitutes a collision? Well, in a snake game, it constitutes hitting the fence. And the fence we have defined as the perimeter around the dimensions. So basically, location 0, 0 in the pitch is a part of the fence. You can basically think of the fence as along the 0th row and along the 0th column and along the n-1 column and the n-1 row. That's basically the fence. So a collision says this position that I am passing here is on the fence. Anything else is outside the fence. And that's basically it. Let's take a look at the pitch itself. To build it, it's real simple. The dimension is required. You have to have that. If you don't have that, there's no way you can do anything. Okay, so it's required. We have getter functions for our dimensions and ID, and here is our collision. Not a whole lot there, is it? It's real simple, too. First of all, we do pass position, and the first thing we do is check to make sure position is an actual vector. We're comparing vectors to vectors here. Next thing we do is we need to find out if this position is in bounds. And what inbounds is, this is a method on a vector. And we covered vectors very early on in this video series. But this method called inbounds basically says, okay, I've got this particular position here, and I'm comparing it to what I consider to be a dimension vector, or a vector that determines a size. And again, earlier I said that the size is 0 to n-1. So a dimension of 40 by 40 would have a row of, or an x of 0 to 39 and a y of 0 to 39. If the x and the y of this position happens to be outside that 0, negative, or outside of 39, let's say 40, 41, or whatever, it is considered out of bounds, and we throw a exception in this particular case, because the position can't be outside of the pitch itself. And if we start throwing exceptions, then your application is got some major problems at that point. Then finally we check for the perimeter, and perimeter again is a specialized vector function that I have built that allows me to sit there and say, okay, does the x value, does that represent a 0 anywhere between, does that represent either let me back up for a second. The position, the x of the position, again I'm using 2D here, is The is parameter will check to make sure that is the x a 0 or is the x the n minus 1 or the n minus 1. The y position will be is y 0 or is y n minus 1. And if it's one of those two numbers, it is considered then on the perimeter or on the fence, and it will return true. Otherwise, it will return false. And that's all there is to the pitch. The pitch is rinky-dink simple. Now, how the UI draws the pitch is a lot more complicated. The HTML is the HTML example that we have here, which we have right here, is actually real simple, and we'll get into that a little bit later on when we do the UI stuff. But the position, the pitch itself, simple as all get out. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.